Hello, welcome. In this video, we're going to be talking about Euler's circle, the 9 points that it hits, and how to construct it in Geogebra. Then, in another video, if you want to see, I'll go through how to construct this using a compass and straight edge. Well, let's get started. This circle represents the unity of all different types of interesting points in a circle. So, for example, what you're seeing here, all these kind of purple lines are altitudes, which are lines that go through the vertex at a right angle to the opposite side. It's essentially the height of a triangle from any given side. Now, every triangle has one, here, two, three altitudes going through each of the vertices. And this circle meets the feet of those altitudes. So for example, this altitude goes through this vertex right here, comes down, hits the other side at this point. That's the foot of the altitude. Well, Euler's circle hits all 3 feet. It also hits all 3 midpoints of each side. So that's pretty amazing, right? This circle already encompasses the feet of the altitudes and the midpoints of each side. It also hits these 1, 2, 3 points, which are the midpoints between the vertices of a triangle and the intersection of all the altitudes, which is called the orthocenter. So if I was to look from the orthocenter to any vertex and go halfway in between, I have another type of point that is crossed by Euler's circle. So this is also referred to as a 9-point circle because it encompasses those 9 points. The 3 feet, 1, 2, 3 of the different altitudes, the 1, 2, 3 midpoints, and the midpoints between the vertices and the orthocenter around the circle. The center of the circle of Euler's circle is also the midpoint between what's called the circumcenter, which is this point, formed by the perpendicular bisectors, and this point, which is the orthocenter. So if you go halfway between the orthocenter and circumcenter, you get the center of this circle, which is an amazing, I just find it wonderful, right? We've got all these different properties of circles coming together in this one shape. That's why it's so exciting to me. And the circumcenter, just to show you this point right here, oh, wrong thing there. I want to do this circle with center through point. So here's my circle, and I'm starting at the circumcenter. I'm going to go through a vertex, and you can see if I click on this one, that circle with that center actually goes through all 3 vertices of the triangle. So the circumcenter and the circle that surrounds the triangle is connected to Euler's circle as well, because the center of the circumcircle, this larger circle here, right here, which is the circumcenter, is the other point used in constructing the center of Euler's circle. And there's other connections there as well. Like there's all kinds of nice relationships between these circles, but every triangle has an Euler circle, and it also represents to me the quest to bring different parts of mathematics together. So these things might seem separate, but there are ways to tie them together. All right, let's construct it using GeoGebra. So in this right here, I'm going to select a polygon tool just to make a triangle. And the first thing I'm going to do is get my perpendicular bisectors. So under this tool, I have perpendicular bisector right here. And to get a perpendicular bisector, I'm just going to click 2 of my points. There's the first bisector. Here's the second. Here's the third. They meet at the circumcenter. Let me mark that point. Go to point, intersect. So I'm going to say, give me the point where those perpendicular bisectors intersect. That's the circumcenter. Now I'm going to drop the altitudes. So I go over to perpendicular lines, and I just pick a point and then a side across from it, and that drops the altitudes. And I'll change the color in just a moment. So we get all 3 of them. So I'm just going around to each vertex and each opposite side, and then I'm going to change those colors so that this is hard to look at already. So I'm going to go to make them purple. There's one altitude, there's another, and the third. So those three altitudes meet at the orthocenter. So that's this point right here. Here's my circumcenter. And if I connect them with a segment, boom, and then get my midpoint, which that tool for me is right over here, I have the center of the circle. I also have the points anywhere a perpendicular bisector intersects a triangle. I already have the midpoint of each side, but I'm just going to use the midpoint tool to get the three midpoints. 2 around the triangle. There's the third one. And I also want to highlight the feet of the altitude. So this altitude meets this segment here, this altitude here, and this altitude here. So I'm going maybe relatively fast, but it's only because I want you to see how this is quickly done. You can always pause and go back, and if you need more support, let me know. I'll discuss it in more detail. Then over here, I'm going to select midpoint, and I want the midpoints between the orthocenter and each vertex because the circle is going to cross those points. And then I think I'm good to go. I've got my 1, 2, 3 feet of the altitudes, 1, 2, 3 feet of 3 midpoints, or the feet of the perpendicular bisectors, and the 3 midpoints between the orthocenter here and each vertex. So I go to my circle tool. This is the midpoint between the circumcenter here and orthocenter here. Click that, and then drag it to any of the 9 points because they're all in the same circle. So I'll click over here, and then I have a dynamic figure, right, that has Euler's circle in it. So in the links below, I will include a link to this Geogebra activity so you can play around with it. And I will also include a link to the slower but also interesting construction of this through the use of a compass and a straightedge. All right, I hope this helped.